In this question, the position of an object having mass 0.1 kg. So mass is given as a 0.1 kg. Time t as a given by r vector. The position vector is given as a vector form, that is r vector equals to 10 t square plus 5 t cube j cap meter. Now at t equals to 1 second, so time t equals to 1 second is given. Now the question is given as which of the following statements are true. So first of all, we want to calculate the values that is given to the question, and then we need to check which option will be true. So first is the linear momentum p vector. So as you know, the linear momentum can be defined as the product of the mass and velocity. Since it is given as a vector form here, then we can write m into v vector. So 0.1 kg into the v vector. To determine the v vector, we can use the formula of r vector, that is v vector, the velocity can be written as the dr vector by dt, that means the rate of change of position. So it is equals to d dt of 10 t square I cap plus 5 t cube j cap. So equals to 20 t I cap plus 15 t square j cap. Therefore, we can write 0.1 into 20 t I cap plus 15 t square j cap. So at t equals to 1 second, we can write t equals to 1 in the following expression of p vector, or also we can write it here, that is therefore p vector at time t equals to 1 second will be 20 I cap plus 15 j cap. From this expression also we can modify, and we can also write the expression directly by putting t equals to mv vector. So therefore p vector equals to m v vector at t equals to 1 second will be 0.1 kg into 20 I cap plus 15 j cap, it is equals to 2 I cap plus 1.5 j cap. That means the linear expansion to expression 2 I cap plus 1.5 j cap of option A is true. Now let's check option number B, the force acting on an object. So we know that the force can be defined as ma vector. The force F vector equals to ma vector. So to calculate the A vector, we have to differentiate the V vector again. That will be dV vector dt. Let's put the value of V vector from this expression. That will be 20t cap plus 15 t square j cap. So it will be equals to 20 I cap plus 30t j cap. Now at t equals to 1, the modified value will be 20 I cap plus 30 j cap. Therefore, we can write the value of force F vector equals to ma vector equals to 0.1 into A vector, that will be 20 I cap plus 30 j cap equals to 2 I cap plus 3 j cap. Newton force can be defined as a Newton. So option B is also right. So option B is also true. Let's check option C and D here. So the angular momentum and the torque is given. Okay. So as you know, the angular momentum can be written as capital L vector equals to R vector cross P vector. That means we need to do the cross product here. So if we write I cap, K cap, K cap. If you want to do the cross product, so R vector at time t equals to 1. So from here we can write t equals to 1 will be 10 I cap plus 5 j cap. It will be 10, 5, 0. P vector that we calculated as a 2 I cap. So that will be 2 and it will be 1.5. It will be 0. As you can see, the component of k cap is 0. So that means I cap, j cap component will be 0. Only k cap is there. So 15 minus 10 k cap equals to 5 k cap joule second. So we can see option C is not matching since it is given 15 k cap. Now let's check the last one, option number D. So this is given as the torque. As we know, torque tau vector equals to R vector cross F vector. So therefore, again, you can do the cross product here, calculate the torque. So R vector will be 10, 5, 0, and the force F vector, that is nothing but 2 I cap, so that is 2, 3, 0. So similarly here also the component of k cap here is 0, that means there are 0 component for the I cap and j cap. So we can directly write the only k cap for k cap. So 30 minus 10, so it equals to 20 k cap Newton meter. So that means option D is also right. That means option A, B, and D is right. Then we need to check which option is correct. ABC is not, BCD is not, ACD is not. So A, B, D only. So that means option number 4 is right. Thank you, everyone.